Hello students, good morning. Let us continue carboxylic acids again. In last lecture, we learned about nomenclature, physical properties, and methods of preparation of carboxylic acids. Today, in this lecture, we are going to discuss about their chemical properties. Before that, let us see about the structure of carboxylic acid functional group. You know, carboxylic acid functional group, carboxyl group has carbonyl group as well as hydroxyl group. Okay, and we can divide chemical properties of carboxylic acids into four categories. In first category, we shall study those properties, those chemical reactions, the chemical reactions involving RCOOH like this. Means this OH bond will get dissociated and loss of H plus will take place. Carboxylic acids will lose H plus, means these will behave like acids. So these are first category of chemical reactions. In second category, we shall take reactions involving cleavage of this bond. This CO bond will undergo dissociation. That means loss of OH negative will take place. And in third category of reactions, we shall take reactions of C as a whole. COOH group will be involved in these reactions. Okay. And fourth category of reactions will be those in which alkyl part will get involved. COOH will not take part, alkyl part will take part in chemical reaction. So these are the four types of various chemical reactions which we are going to study today. Let us take first category, reactions involving dissociation of OH bond and loss of H plus. They like acid. Under this category, let us take a reaction RCOOH plus sodium. If we put sodium, a small piece of sodium in carboxylic acid and heat, what we see, we get RCOONA. Carboxylic acid molecule gives H plus. We can balance it. So H2 gas is evolved. So in lab, we can get H2 gas from the reaction of carboxylic acid with the sodium. Okay. Then second reaction, if we take carboxylic acid along with a base NaOH, you know, base gives OH negative, acid gives H plus, loss of water and salt is formed. Again, we get RCOONA. Salt RCOONA. It is called sodium carboxylate. Okay. Then, if we take carboxylic acid and put sodium hydrogen carbonate to it, even then we get the same salt, sodium carboxylic acid, along with loss of carbon dioxide and water. So all these reactions are proving that carboxylic acids are acidic in nature. Now question is, why carboxylic acids are acidic? Let us explain. Because these give H plus, you can say, but why these give H plus? It is because if we see a molecule of carboxylic acid, RCOOH, it is having carbonyl group as well as alcohol group, but it does not show most of the properties of carbonyl compounds as well as alcohols. Of course, they are having carbonyl group as well as alcoholic group, but their properties are different from both. Why? Because you see there is lone pair, then single double conjugated system, there will be resonance. This lone pair will spread over this single bond, and this pi bond will shift here in the form of lone pair. The structure will get converted to this structure. Negative charge here, double bond, O, H, and positive charge. Okay. Now the lone pair will come back at this single bond, and this bond pair will become lone pair again, and this structure will again get converted to structure B. Now, these two are the resonating structures of carboxylic acid, and their hybrid of these two structures will be like this. This structure will be having common features of the resonating structures. This O will have partial negative charge, this O will have partial positive charge. So this is resonance in carboxylic acid. Okay. And resonance provides extra stability to a molecule. But you see, there is some problem in these resonating structures. You see, one of the O atom is having negative charge and other is having positive. O is electronegative. It should not have positive, but it is here. Okay. Now let us see resonance in carboxylate ion. When carboxylic acid molecule lose H plus and behave like acid, when H plus is given out, the remaining part is called carboxylate ion. This is carboxylate ion. This carboxylate ion is also resonance stabilized. How? Let us see resonance in carboxylate ion. when carboxylic acid molecule lose H plus. Okay, one of the O gets negative charge. Two lone pairs are already there on both O atom, but this O is having 3 lone pair because it has lost H positive. So this is carboxylate ion. Now see, this lone pair will become bond pair here, and this bond pair will go over this oxygen in the form of lone pair. And this structure will become like this. See, this negative charge has vanished and this O has got a negative charge. Again, this lone pair will shift here in the form of bond pair, and this bond pair will become lone pair, and these two structures will resonate. These are resonating structures, and hybrid of these two structures will be like this. Both the bonds have partial double character. One negative at 2O divided, partial negative, partial negative. So this is the resonance hybrid of carboxylate ion. Now, if you keenly observe these two structures, this hybrid and these two structures, you will see that these structures are not equivalent. One of the O is having negative, one of the O is having positive. But here, if you see these two structures, you will see that these two structures are same. If I flip this structure like this, I will get this. You see, देखो, इसको अगर ऐसे पलट दें तो ये बन जाती है. मतलब वो एक ही चीज है ना? तो ये दोनों स्ट्रक्चर्स इक्विवेलेंट है. एंड रेजोनेंस का रूल है, आपने पढ़ा 11th में. When structures are more equivalent, they provide more stability. So, इसकी ऑब्जेक्शन क्या है कि एक तो स्ट्रक्चर्स इक्विवेलेंट नहीं है. दूसरी प्रॉब्लम क्या है कि O इलेक्ट्रोनेगेटिव है बट उसके ऊपर पॉजिटिव चार्ज है. So therefore, resonance in carboxylic acid is providing less stability as compared to resonance in carboxylate ion. So resonance in carboxylate ion is providing more stability. That is why carboxylic acid molecule gives H plus, becomes carboxylate to get more stability. That is why carboxylic acids are acidic, and those reactions are proving that these are acidic. Okay, so this was the first category of chemical reactions in which carboxylic acid molecule is losing H plus by dissociation of OH bond. Now let us study second category of reactions. Means reactions involving RCOOH. Cleavage of this CO bond will take place here. Loss of OH will take place. Okay. First reaction of this category is reaction with PCl5, PCl3, SOCl2, HX. ये सारी, these all we have already learned somewhere. तो बड़े कंफर्टेबली आप इनको कंप्लीट कर सकते हो. कैसे? कार्बोक्सिलिक एसिड प्लस PCl5 टू गिव OH. लॉस होएगा, OH को रिप्लेस कर देगा Cl. we shall get acid chloride, loss of POCl3 and HCl. Simple. This is canoyl chloride, acid chloride बन जाता है, IUPAC नेमिंग ऐसे करते हैं. Second, if we put PCl3, RCOOH plus PCl3 को याद करवाया था अल्कोहल्स में भी कि यहाँ पे 3 मॉलिक्यूल्स कर देते हैं बैलेंस करने के लिए, और H3PO3 loss and 3 molecules of again RCOCl. Then SOCl2 के साथ करें अगर रिएक्शन, SOCl2 means thionyl chloride. ओके, तो क्या होएगा? अगेन SO2 गैस, HCl gas, RCOCl, and finally if we put HX, value of X will be Cl or Br. So you will get RCOX, loss of water. So this is first type of reaction in which we have used these 4 reagents. Okay. Now second type of reaction, number B. Number B is anhydride formation. A molecule of carboxylic acid, when heated in presence of some dehydrating agent like P2O5, what happens? 2 molecules of acid interact. One molecule gives H plus, the one gives OH. Loss of water is formed. See, this is one molecule, this is other molecule. Now, if you are going to take a mixture of 2 carboxylic acids, we can put dash here, R dash. R and R dash can be same or different. Then one molecule gives OH, other gives H. Loss of water, and this is RCO, OCO, R dash. This is acid anhydride. Acid anhydride की नेमिंग कैसे करते हैं? If both R are same, then एक ही तरफ के काउंट करके alkanoic anhydride. But if both are different, तो दोनों का alkanoic सेम नहीं होएगा, तो फिर दोनों का अलग अलग बना के अल्फाबेटिकल ऑर्डर में alkanoic anhydride. This is it. Okay, so this is acid anhydride. Now next reaction is esterification. Esterification means formation of ester. तो इस रिएक्शन में ईस्टर बनेगा. See how? If we treat carboxylic acid with alcohol, alcohol is ROH. Okay, acidic medium है, this reaction is reversible. So acidic medium takes it to forward direction, and mind it that in this reaction cleavage of CO bond of carboxylic acid take place. Mechanism is there, but I think it is not in your syllabus. If it is there, we will do it. Carboxylic acid gives OH negative and alcohol molecule gives H plus. Loss of water takes place, and what remains is RCOOR, and this is ester. Okay, and esters are named as, this R is called alkyl, this chain is called alkanoate, alkyl alkanoate, and esters are sweet smelling, fruity smelling compounds. All smells of fruits are due to esters. These are produced naturally among fruits. Okay, so this is esterification. Next reaction of this category is reaction with ammonia. Type D, reaction with ammonia. Carboxylic acid plus ammonia, HNH2, NH3, you can say NH3 ammonia. Now, ammonia, when reacts with carboxylic acid, because carboxylic acid is acid, it gives H plus, and ammonia has lone pair of electrons on nitrogen. Okay, so this lone pair will extract this H plus, and reaction will take place like this: RCO, O negative, and NH4 positive. And this salt will be called ammonium carboxylate. Okay, ammonium carboxylate. But when it is heated strongly, what happens? 2 H atoms and 1 O atom is given out in the form of H2O, and the remaining thing is RCONH2, that is acid amide, alkanamide. Okay, it is derivative of carboxylic acid. So alkanamide can be prepared by ammonolysis of carboxylic acid. Okay. Then, if we replace benzene ring here, then it is benzoic acid, of course. In a similar way, benzoic acid reacts with carboxylic acid to give ammonium benzoate. Okay, which on strongly heating will release water and form aromatic amide called benzamide. Okay, so this is it. Now let us take one more example in which we are taking a dicarboxylic acid. What is dicarboxylic acid? A carboxylic acid having two functional groups in one molecule, two COOH groups. Let us take this dicarboxylic acid. This is benzoic acid, and if at ortho position one more COOH is substituted, then it is called phthalic acid. When phthalic acid is subjected to ammonolysis, we are using two molecules of ammonia. In a similar way, both molecules need H positive, and this phthalic acid will get converted into ammonium phthalate. C double bond O, single bond O नेगेटिव, इसका H प्लस एक अमोनिया के साथ क्या बन गया, NH4 पॉजिटिव. सिमिलरली इसका H प्लस दूसरे अमोनिया के साथ बन गया NH4 पॉजिटिव. तो थैलिक एसिड था, तो ये क्या बोलेगा, अमोनियम थैलेट साल्ट बन गया. ओके, इसको हीट किया स्ट्रांगली. अगेन यहां से 2H और ये O, 2H और ये O, लॉस ऑफ 2 molecules ऑफ वाटर. देन नेम ऑफ दिस प्रोडक्ट विल बी, यहां पे आ गया NH2, CONH2. सिमिलरली दिस इज CONH2. ये भी अमाइड बना क्योंकि थैलिक एसिड से बना. सो दिस इज thalamide. This is thalamide. And when we heat this thalamide strongly, further heating, on further heating, this thalamide is converted to thalamide. How? One NH2 and one of the H from here is given out as ammonia. Cyclization takes place. बेंजीन रिंग थी, बेंजीन के साथ यहाँ पे C डबल बॉन्ड O, C डबल बॉन्ड O, ये N था इसका, दूसरे वाले का N, दोनों H, इसका एक H चले गए, ये N दोनों में कॉमन हो गया, इसके ऊपर एक H रह गया बस. सो दिस, ये भी एक रिंग बन गई, दो रिंग्स हो गई है. So this compound is called thalamide. ओके, तो केमिकल प्रॉपर्टीज में हम एक रिएक्शन पढ़ेंगे, गैब्रियल्स थैलेमाइड सिंथेसिस. तो वहां पे ये रिएक्शन आपको काम आने वाली है, तो आपको इसको ध्यान से समझ लेना है. तो टुडे वी हैव लर्नड chemical properties of carboxylic acids, in which carboxylic acids give H plus, then in which carboxylic acids give OH negative. In next lecture, we shall study the properties of carboxylic acids in which COOH group participates as whole. पूरा का पूरा ग्रुप भी इन्वॉल्व होएगा COOH. एंड देन लास्ट में कुछ ऐसी रिएक्शंस पढ़ेंगे जिनमें COOH ग्रुप का कोई काम नहीं है. जो भी रिएक्शन होएगी दैट विल टेक पार्ट ऑन, दैट विल अकर ऑन अल्काइल पार्ट. ओके, सो आज के लिए दिस इज सफिशिएंट. लेट अस मीट टुमारो. टिल देन, गुड बाय, थैंक यू.